This video will help you with the Bayes estimate homework problem. We're going to begin with an event tree. This event tree is based on a levee. A levee is a mound of earth built alongside of a river to provide protection against flood flows. Levees can sometimes fail, and interior seepage is a reason for levee failure at times. Interior seepage is a condition inside the levee that's usually not seen. So here's what our event tree is saying. It begins with the question of whether the levee fails or not. Yes, 2% of the time. No, 98% of the time. These initial probabilities, we'll consider them subjectively estimated probabilities. That's your prior information, the information that you begin with. Next we move to column D, and here we're going to assume that we get some new information from a survey about interior seepage. And this survey shows that when levees have failed, 60% of the time there was a problem with interior seepage. 40% of the time there was no problem with interior seepage, even though the levees failed. When the levees did not fail, 31% of the time there was a problem with interior seepage. 69% of the time there was no problem with interior seepage. So let's review what we have here. We're going to begin with a little bit of terminology, and the first term we're going to look at would be prior probabilities. This is the information that we begin with, and if you begin with no information, you would generate it subjectively, or possibly in an expert elicitation. But the probability that a levee fails is 2%. The probability of no levee failure is 98%. Then we have conditional probabilities. First, we have the condition probability that there is interior seepage given that there was a levee failure. Well, here we have the branch that gives that there is a levee failure, and we see 60% of the time there was interior seepage. So that 60% is a conditional probability. The second conditional probability is the probability that there is interior seepage given that there is no levee failure. Well, here we have no levee failure, and here we have the presence of interior seepage, 31%. You will notice that both of these probabilities are nominally at least the probability of interior seepage, but those probabilities differ. One is 60%, one is 31%, and that's because there are different conditions attached to each. Next we go to joint probabilities. Joint probabilities are sometimes conveniently called AND probabilities, and this is why. Here we have the probability that there is levee failure and interior seepage. So this is the probability of a levee failure and interior seepage. So 2% times 60% equals 1.2%. 0.012 is the joint probability, or the AND probability. Here's the probability of no levee failure and interior seepage. This would be the probability of 98% times 31% for 30.38%. Notice now, 0.012 plus 0.3038 equals 0.3158, and this is the entire probability of interior seepage. So if we get rid of the conditions and we said, what is the probability that a levee has interior seepage, that would be 31.58%. These values are given in column E. So notice here is the joint probability of failure and interior seepage. This is the joint probability of failure and no interior seepage. No failure and interior seepage. No failure and no interior seepage. But we're interested in the probabilities of interior seepage, so that involves this value and this value. When we add them, we get 31.58%. The next bit of terminology that we're going to examine would be the posterior probabilities. This would be the revised probability. Imagine that we are trying to answer the question, what is the probability of levee failure given that there is interior seepage? This would be useful to have because we might do an inspection that turns up some evidence of interior seepage, and we'd like to know now, how does that affect the probability that the levee is going to fail? Initially, we used a 2% chance of levee failure, but we now have some information. If we know there's interior seepage, how does that probability change? And the answer is embodied in our posterior probabilities. Here's the probability in the question. The probability of levee failure given interior seepage. And this is obtained by taking the joint probability, 0.012, and estimating what part of the entire, or the sum of the joint probabilities that represents. So that's 0.012 divided by 0.3158, which yields a revised or posterior probability of 0.038. Here is another posterior probability, the probability of no levee failure given interior seepage, and that's given by the joint probability divided by the marginal probability of interior seepage. So that's 0.962. Consider that information here again. We began with a subjective estimate of the probability that a levee fails of 0.02 or 2%. Then new information becomes available from a survey that shows the probability of interior seepage given that a levee has failed is 60%. So imagine that this information was an after-action report that showed in levees that failed 60% of the time, we find evidence of interior seepage. Further, imagine that this information uses information obtained from levee inspection reports. And so the probability of interior seepage given no levee failure is 0.31. So these are the probabilities that you see up here in our event tree, and these are the conditional probabilities. So this is the new evidence that is introduced into our problem. The next thing that we do is to apply Bayes' theorem. And we do that with the formula that you see in the cell there. This is the probability of levee failure and interior seepage. So this is a joint probability, and it is divided by the probability of levee failure and interior seepage plus the probability of no levee failure and interior seepage. So that denominator there, that is the total probability, the sum of the joint probabilities that was calculated here. And this is nothing but the marginal probability of interior seepage. So Bayes' theorem means taking a joint probability and dividing it by a marginal probability. And that's what happens in the cell F26 that you're looking at there. 0.012 divided by 0.3158 gives us the revised probability. We began with a probability estimate of levee failure of 2%. We have now found out that if there is evidence of interior seepage, that probability changes. It changes from 2% to 3.8%. So this is the revision that we're talking about. In the remainder of this exercise, you will find some additional information. We have joint probabilities calculated here, and we show you how they play into the posterior probabilities. This is just a repeat from the information above. In these cells here, we try to put into words what's happening here. So you have learned from the probability review that a conditional probability is a joint probability divided by a marginal probability. So these next two rows provide examples of a joint probability divided by a marginal probability. You'll see row 37 presents the simplest notation, and row 38 breaks the probability, the marginal probability of interior seepage, down into its component parts in the manner that we were just looking at. Rows 40 through 42 take the formulas that we are just talking about now and transforms them into a general kind of formula, where instead of levee failure we use A1, and instead of no levee failure we use A2. Instead of interior seepage we use B. So with terms like A1, A2, and B, we get a generalized form of Bayes' theorem. In rows 44 and 45, we present Bayes' theorem in a slightly different form, using some information about the joint probability that was also obtained from the video lectures reviewing our probability ideas. The remainder of this exercise, the remainder of this page of the exercise, provides the information once again. Here you see levee failure and notation for levee failure along with the probability of levee failure. Probability of no levee failure. And then we have our conditional probabilities, and they all are arranged down here in a little color coded. We begin with the prior probabilities in yellow, conditional probabilities in beige, the joint probabilities, these are estimated in the blue cells, and the posterior probabilities in green. What you may or may not find useful here, if you click into any one of these cells, for example D61, if you look up into the formula bar here, you'll see that's referencing a value in the table. You can look at all the formulas, they are all referencing calculations, so that you could change any of these values here. We could change this from a 0.02 to a 0.05. We have to make sure that we obey the complementary law of probability. 0.95, and you can see how the values change here. The probability of levee failure is revised from a 5% chance to a 9% chance. So it gives you an opportunity to play around with the numbers some. If you prefer, you can change any of these values as well. So have a look at this exercise. Once you're familiar and comfortable with it, you're going to go on to the exercise tab, and in this space here, in these gray spaces, you are going to duplicate these calculations here. So if you have any questions, please feel free to ask.